Hi guys, all right, so let's do some review this week. So I had to cross off some things because it's in the statistics unit and I didn't get to teach you that yet. That's our last one. So we'll cross off 1 and 2 and let's go into number 3. All right, so it says, which statement about the graph of c of x equals log base 7 of x is false? So what I would love for you to do is to graph it. You can graph it on your calculator, or we could graph it based on what I wrote here below. What do we remember? So if we're graphing a log graph that doesn't have any kind of horizontal or vertical shift, it's going to pass through 1, 0. And then remember, it always passes through base, 1. So our base is 7. So we know this is going to pass through 7, 1. So 1, 2, 3, 4, 5, 6, 7. So 7, 1. And remember, we have a vertical asymptote at x equals 0. And there we go. All right, so we make a little sketch, and now we can go ahead and we can figure out which one of these is false. Okay, so the asymptote has the equation x equals 0. Well, that green line is the equation of the vertical asymptote. That is x equals 0. Remember when there was stuff going on in here, we used to always set that equal to 0 to find the vertical asymptote. All right, the graph has no y-intercept. Well, that looks pretty good too. Doesn't look like it's going to cross, so that's true. The domain is the set of all real numbers. Remember, domain is the x-axis, right? With the x direction, how far to the left, how far to the right. And we can see that this is going to go all the way as far as possible to the right, but it's going to keep approaching x equals 0. So the domain is the set of all real numbers. That would be the one that's false, because the domain here is x is greater than 0. And remember, we used to set the bubble greater than 0 to find the domain. Okay, the range. Range is how high, how low, right? So this graph is going to go forever down, and it's going to go forever going up. So that would be true. The graph passes through 1, 0. Yep, we can see that too. True. So here we go. Choice 3. So I always think it's best to graph it and then, go through all of the options. Okay, next question. So this is the one that the unit that we just did, the series and sequence unit. It says Mary earns $53,000 in her first year of teaching and earns a 5% increase in each successive year. As soon as you see that percent, we know this is exponential, we know it's geometric, and then it says write a geometric series formula, S sub n. So remember, that's on our reference sheet. So for Mary's total earnings over n years. All right, so I wrote down the formula. Remember, you have to take this 5%. Remember, decimal to percent. We need to change it over. So it's going to move the decimal 2 places to the left. But I can't make my R value, my common ratio, 0.05. If you multiply by something smaller than 1, the number is going to become smaller. And we know that this is an increase. So remember, it's always 1 plus the rate. So 1 plus 0.05. So in this particular case, your common ratio is 1.05. Now, also look here, we're writing a formula, so that means we're going to have 2 variables, right? So our first answer to the question here is not going to be a number. It's going to be like you're going to have a y and you're going to have an x, except S sub n is your y. So my initial is 53,000 minus 53,000. Your common ratio raised to the n, that's like your x, all over 1 minus 1.05. That's your first answer. Don't do anything with that. That's it. You're writing a model, an equation, a formula, something that we can use to predict. So that's it right there. Now the next part. Use the formula to find her total earnings after 10 years. So now we'll just substitute n in. So S sub 10 equals 53,000 minus 53,000. 1.05 raised to the 10th over 1 minus 1.05. throw that in your calculator carefully. You know, please make sure you guys do that with me. Oopsie. Yeah, I hope I didn't make a mistake on that first question either, because my daughter was using the microwave, doing things. I was getting distracted, so hopefully not. Okay, and then it says near cent. So my answer is going to be $666,000. $666,628.30. Okay, so that's the unit we just did. So hopefully that one went well for you. Okay, next. So you guys were always great at this. The average rate of change. So which function has a greater average rate of change? Remember, that's just slope. So I wrote down our formula. If we're gonna do slope, we need to have 2 points. So I can see here, those are my x values. So it's -1 to 3. And I'm gonna do that for the f function. And I'm also gonna do -1 to 3 for the g function. Now for the f function, it's right there in the chart. So -1's partner is 1.5 and 3's partner is 24. And then we'll just do our slope formula. I always find it helpful to label. Got a little more room. Okay, so we have m equals 24 minus 1.5 over 3 minus -1. And we got 5.625. Okay, next guy. Now this one, you could just put this in the calculator and go to the table and find the partner for -1. And same thing for 3, or you could do it algebraically, but I suggest, putting in the calculator. Here's your x1, your y1, x2, and y2. Okay, so 23 minus -1. Whoa, that's big. Over 3 minus -1. My daughter has to wash dishes while I make the video. Has to. M equals 6. Okay, so which one is greater? So g of x is greater. And there we go. Okay, so I think you guys are really good at that. All right, number 6. Now, number 6, I'm going to do some of it, but then I do want you doing the rest of it. So I'm not going to do the whole entire thing with you, but I set it up nicely. Okay, so let's look. And we've done this so many times before. Drugs break down in the human body at a different rate and therefore must be prescribed by doctors carefully to prevent complications such as overdosing. The breakdown of a drug is represented by this function. So we see that this is E, right? So this is continuous. Now remember with E, look, it's got a negative exponent. Negative exponent means that this is a decay model, but they tell us it's decay anyway as we read through. Okay, so I use the highlighter here so that you could see where each one goes. So we got patient A is given 600 milligrams. So remember how this formula works. Who cares what variables they're using? Isn't N of T what it becomes? Isn't N sub 0 the initial? And then E we know is going to be continuous, and there again, this is negative, it's going to be a decay. Okay, so I just plugged in. 600 is the initial. Now look, when I put in the decay rate, look, negative. A lot of times you guys leave that out. And also the T, you guys tend to leave that out in the calculator. Now you can't put T in the calculator, right? You have to put X. If you don't put an X there in the calculator, you're going to get a straight line. You're going to get the same number in the Y column every time. And that's a common mistake you guys make. Okay, patient B, 300 milligrams is my initial. Look, here's my decay rate again, but you have to put the negative in, right? The formula has a negative. And you guys have to put T there, but in the calculator, you're going to put X. Okay, so I set you guys up. You have to do the rest, okay? You guys have to plug that in the calculator, fill out these tables for me. We're going to start at 0, right? Initial value. I want to see the graph done, and then I'll do this part with you, okay? But you guys have to do the other one. All right, so I tried to highlight and put it so you know which parts I'm doing here again, too. So it says, to the nearest hour t, when does the amount of the drug given in patient B exceed the amount given in patient A? So you're just finding the point of intersection. So you would graph both of those in your calculator. You will have to adjust the window, right? Because you're starting at a value of 300 and you're starting at a value of 600. So in your calculator, you're going to have to make your Y max. I would make it go to like 800, like go past 600. Okay, so the only thing you really have to adjust is Y max. Well, I would probably adjust X max to be like 10, and then you should get a nice picture. Okay, second part of the question, the yellow. The doctor will allow patient A to take another 600 millimeter dose when 15% of the original is left. Sorry, my daughter has to scrape her bowl eating peas. You're crazy. Oh my God. All right, sorry. So look, I took 15% of 600, and I got 90. This is one way to do it. I have shown some of you that you can just insert the 15% over there, like the 0.15, but most of you are probably going to do it this way. All right, so let's go ahead now and solve. So look, we're solving for an exponent. Remember, it's an exponential equation when we're solving for an exponent. So I'm going to divide by 600. Boy, that's a fat pen. Let's make this one skinnier. So we're going to get 0.15 equals e to the negative 0.368t. And remember what we would say in class? We'd be like, can we get the bases the same? Can we get 0.15 and e to be the same base? That's impossible. E's irrational. So we're going to take the log of both sides. So we're going to do ln, the natural log, right? Well, oops, so what's going on here? Okay, so ln of 0.15. And remember we used the power rule as well. So negative 0.368t ln of e. ln of e we know is 1, or you can put it in the calculator if you don't remember. We're solving for t, so divide through. Remember, you can pause the video anytime. I'm just trying to teach through here a little bit so that the videos aren't like so long. Okay, so 5.155, blah, blah, blah. We're rounding to the nearest tenth, so my answer, right, I look right here, one place to the right. If it's 5 or greater, it pushes it up. So 5.2 hours. Alrighty, that was number 6. We got 2 left here for review topics number 1. Okay, 7. It says the graph f of x is a cubic function. State the zeros, multiplicity, and a possible equation. All right, so the first thing I did is identified that this is odd, right? Because the end behavior, they're going opposite directions. And positive, right? Because it's righties up. All right, so the first thing I'll do is I'll check out the zeros. So I have a 0 at 1. Now that looks like it's going straight through, right? So this is x equals 1, so that means the factor must be x minus 1. This one is x equals negative 3. The factor must be x plus 3. This one, I can tell that it's bouncing or kissing, remember? So it has to have an even multiplicity. So f of x equals x plus 3. We'll hold off on the exponent for a second. And then x minus 1. All right, so I know this is 1 because I can tell it's going straight through over here. Now, this exponent has to be even, but they already told me it's a cubic function. So remember, the exponents must add to be 3. So the only even exponent that could be is 2. All right, so this is a possible equation right here. And you don't need to have the 1 there, but you can put it if you want. All right, looks good. All right, last one for review topics 1, number 8. It says the graph of the polynomial function, blah, 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 blah. And it says, what does the real solution appear to be? So the real solution, right, zeros, where it crosses the x-axis. So the real solution appears to be x equals 2. Prove algebraically that it is. Well, if I think that that is a solution, then can't I just use the remainder theorem? And I can substitute in and see if I get 0. Okay, so this is just the remainder theorem. Throw that in your calculator and you do get 0. You proved it. Now, if they tell you to prove it, it means that it is. Okay, last part. Write f of x as a product of a linear factor and a quadratic factor. Well, we already have the linear factor, don't we? It's got to be x minus 2. So now I need the quadratic factor. So we can just do a little long division. So I'll do x minus 2 divided into, now make sure there's no placeholders needed, but I don't think we have any. So x cubed minus 5x squared plus 11x minus 10. All right, so we'll just do a little long division here. So remember, what am I going to put right here? So when I do the distributive property, that I will get x cubed, so this would be x squared. So now distribute. I get x cubed minus 2x squared. Big fat minus sign. X cubed minus x cubed is nothing. And then be careful with this one. Negative 5 minus negative 2 is negative 3x squared. Use your calculator if you need to. Plus 11x. And then you start the whole process again. You know, what am I going to put up there so that when I distribute with the x, I get negative 3x squared? So negative 3x. And distribute again. And you guys are so good at this. Negative 3x squared plus 6x. Big fat minus sign again. These first two guys better wipe out. And then 11 minus 6 is 5x. Bring down your negative 10. Let's see if I can get some more room here. I think I can write on that. Okay, and then one more time. I'll distribute with a 5 to get, oops, I gotta go here. 5x minus 10. And there we go. Okay, so what does this mean? This means that x minus 2 times x squared minus 3x plus 5 gives me that polynomial function that I started with, that cubic function up top. Okay, so now they want me to write the answer as a product of a linear and quadratic factor. So this is my answer. F of x equals x minus 2 times x squared minus 3x plus 5. Okay, great question to know. All right, guys, so that is the end of review topics 1. So I wanted to like split it up for you, you know, like, so review topics 2 will start with number 9, but I just want to split it up so you had, you know, you could take a break and do 2 different videos and then submit for me separately. All right, thank you. Hope you, you know, just work on schoolwork today. Today's such an icky, rainy day. Maybe you can get it done today, which is Monday. All right, bye.